recording. Can you see the whiteboard now? Can you see the whiteboard now?
Yes, yes.
Okay. Just see if you can figure out what's being written. Can you see what's written on the whiteboard?
1 minus
Yeah,
alpha.
that's correct. Perfect. Let's begin. So today, what did we do yesterday? Yesterday, what we did was we tried to figure out, given a time series, we wanted to figure out what stochastic process generated that time series, right? Is it an AR1 model, AR3 model, MA1 model, MA4 model? What is it? And we saw that the way to determine that is through computing ACFs and PACFs from the sample. Okay. So today, we'll just do a very quick session. I promise not to take more than 20-25 minutes. What we essentially want is, once we have figured out what is that stochastic process, underlying stochastic process, which is generating the time series, the realization of which is the time series, the data, the next step is to estimate the model. Okay. So let's say if you have a time series, so I'll just show you how to do that. So let's say if you have a time series, a data like this, y1, y2, dot, 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 y capital T. This is your data. Is it okay, Abhyuday? This is how your data looks like.
Yes.
And let's say if you have done your ACF and PACF test, which we talked about yesterday, and you figured out that okay, this probably follows an AR1 model. Okay, that is, the underlying stochastic process looks something like this. Where your epsilon t okay, clear. Now the question is, that's your underlying stochastic process. Very good. Now you want to find out what is the likelihood of this set of observations happening. What is the likelihood of this set of observations happening? Usually, recall when I taught you maximum likelihood, what did you have? You had a bunch of random variables. You knew the distribution of every random variable. And then you have these observations. And then what you do is the following. Your likelihood usually looks like this. Correct? Abhyuday, Vaibhav, is it correct? That's how your likelihood looks like.
Yeah.
Yeah. And then
Yes.
then there are some parameters of these density functions, and then you maximize this function with respect to those parameters. Correct? That's what you do. But here, you don't really know the densities of all the y's. But instead, you know that the y's are being generated by a stochastic process of this kind. Is it okay? So how will you find this out? The way of finding this out is the following. So what you do is this. So what is it that you want to find? Loosely speaking, again, I'm saying loosely speaking, these are continuous random variables. So of course, this is incorrect, but loosely speaking, this is what I want to find. Right, Vaibhav? Vaibhav, can you hear me?
Yes, yes.
That's what loosely we want to compute. But we don't really know. See, had they been IID, had they been independent, then I could have written this, right? But now the YTs are not even independent. They have some joint distribution. Of course, they are connected, right? YT is connected to YT minus 1, which means all the YTs are connected through time. In that case, how will you compute this likelihood function? Well, what you do is you use conditioning. So this can be written as probability of capital YT given can I write it like this? Let me write it a little more precise manner. So this can be written as, so this is, let's say, density. So this can be written as, so this is actually not P, but density, let's say. So this can be written as correct. Isn't it true? So this is again loosely speaking. So this is approximate. So this is now, this can again be written as do all of you agree with this? I'm simply writing in terms of conditional probability or conditional density. Hello.
Yes, sir. Yes, sir.
Yeah. So this is the idea we are using here. So let me write it a little more correctly and formally in the next. So what do we have here? We have, let's say AR1. Let's say you have figured out that the data follows an AR1 process. This is how your data looks like, by the way. Okay. This is your data. The realization. And you see that your stochastic process is of this kind. And your epsilon t follows normal. So what did I just say? So what is the joint density of this data happening? It's simply the density that capital YT will take this value, conditional on these, which is again into multiplied by, isn't it so? Which is Ananya? Correct? Simple conditioning, conditional density.
Yes.
You can, I'm just writing one more step maybe. You can further write this as, what will you write this as, Vaibhav? Y t minus 2 given y1.
Conditional upon 1 till p minus 3.
That's very good. Into density of so on and so forth. So if you keep on doing this, you just keep on doing this. So this will carry on till f of y2 given y1. Right? That's where it will end. That's where it will end. We start with y1, that's given. And we carry on this conditioning, and it will finally lead to y2 given y1. Yes, everybody? Yt given y1 to yt minus 1, then yt minus 1 given it's past, then y2 minus 2, t minus 2 given it's past, dot, 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 up to y2 given it's past, which is y1. Y1 has no past, so that's just y1. Is this okay? Clear? Is this clear?
Yes.
Hello. Yeah. Now, okay. Now, keeping this in mind, let's see how this likelihood function will end up looking. Remember, your epsilons are normal random variables with mean 0 and variance sigma square. So remember this expression, and now let's see how we can do this. Now, what is, so this is our stochastic process, remember. Phi yt minus 1 plus epsilon t. Right? Now, what is expectation of yt given it's past? That's what we want to figure out, right? What should it be? Well, it's simply do all of you agree with this? I'm just taking conditional expectation on both sides. Okay. Now, if it is given till yt minus 1, what is expectation of yt minus 1? What is expectation of z given z? Well, it's simply that value. Simply that value. What about this? This is the expectation of the today's randomness given all information till yesterday. Well, that's simply 0. That's equal to the unconditional randomness. Remember, today's randomness is independent of what happened till yesterday. That's our exogeneity assumption in this particular case, in this time series scenario. Your epsilon t's are must be independent of yt minus 1. And that's also intuitively obvious, as we discussed yesterday. So this is simply phi t minus 1. Ananya, isn't it true? Akshata, can you hear me?
Yes, sir.
So that's true.
Yes, sir.
Now, what is the conditional variance? Now, I'll tell you why am I finding the conditional mean and conditional variance of yt. I'll tell you. Or maybe some of you can already guess why am I doing this. What is this? Well, this is simply expectation of yt minus conditional mean of yt Oh, what happened? Yeah, can all of you see the whiteboard? Can all of you see the whiteboard?
Yes, sir.
Yeah, okay. So that's what you have, right? Now, what is this yt minus the conditional expectation? The conditional expectation is simply phi t minus 1. What is yt? Phi t minus 1 plus epsilon t, right? So what is yt minus this conditional expectation? It's simply epsilon t square, isn't it? Hello. Abhyuday?
Yes, sir.
Is it absolutely clear?
Right. I can't see the last line you've written, sir. I think you have to scroll. If you can just scroll.
Just a second.
Is that possible?
Can you see it now?
Yeah, yeah. Yeah, that makes sense.
That makes sense, right?
Yeah, yeah.
Yeah. Now, again, epsilon t is independent of what happened till t minus 1. So this expectation of epsilon t square is simply the unconditional expectation of epsilon t square. It's anyway not dependent on this conditioning. So it's simply this. And what is this? Expectation of epsilon t square? That's variance of epsilon t. And remember, your epsilon t follows normal 0 sigma square. So this is simply sigma square. All of you agree with this? Are we on the same page? Motiyar? Motiyar's mic is not working. Akshita? Alak, can you hear me?
Yes, sir.
I think Alak is online. Alak?
Yes, sir.
Yeah, is it clear?
Yes, sir.
Do you have any questions? Please ask me.
No, sir, it's fine.
It's fine, right? So you see that, oops, okay, the Zoom meeting is about to end. I guess I'll have to send you one more link. I'll do that in a second. So you see that your yt given, from this you can conclude that this yt given yt minus 1, this random variable, this conditioned yt, follows normal with this, the conditional mean, and variance sigma square. Is it clear? Do all of you agree with this? Yes, Vaibhav? Vaibhav, do you agree with this?
Yes, sir. Yes, sir.
Yeah, that's correct. Since epsilon t is normal, so your yt conditioned on y1 to yt minus 1 is also normal. And I've already found the mean and variance of it. Okay, fine. So now using this, we'll move ahead. Let's see what to do. Now you know what was your likelihood function? It was f of yt given y1 to t minus 1 into f of yt minus 1 given y1 to t minus 2 dot 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 dot. Something like this. Now, what is this? What is this then? This follows what? Your data is like this. And you know, this follows normal and this is your data. So how will this total likelihood function look like? It will simply be, small phi, but I have already used the symbol phi, so I'll just write the so this is simply 1 by root over of 2 pi sigma e to the power minus 1 by 2 sigma square yt minus phi yt minus 1. Correct? Do all of you agree with this? Square. That's for the first term. Yeah. What about this? What about this? This is the density function of a normal with mean this and variance this. Right? And these are your observations. So this is how the likelihood of this particular observation looks like. Correct? Vaibhav?
Yes, sir.
This will be what? Abhyuday, do you get it?
Yes, sir, I'm getting it.
So this is y t minus 1 minus phi y t minus 2 square dot 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 dot. Correct? Isn't it, sir? So this simply will become, if you take this apart, this is to the power t minus 1, I guess. And you have e to the power minus 1 by 2 sigma square summation of yt minus phi y correct? And then you minimize this likelihood, then you maximize this likelihood with respect to what? Tell me. Phi and sigma. These are your two parameters. Correct? Correct, Vaibhav?
Yes,
Vaibhav?
sir.
Yeah.
Yes,
And
sir.
once you have found that, now you know what your parameters are. Now you know the stochastic process. What was your stochastic process? Yt equal to phi yt minus 1 plus epsilon t, where epsilon t has mean 0 and variance sigma square. So the only two parameters of your model were phi and sigma, and you've estimated them. You're done. Okay. Okay. So we'll do two more things in the next meeting. So let me just send you the link in your emails. So please check your emails now. Okay. I'll just send you the mail with a second Zoom link.